Welcome back. Myself Hemant. Today I'm going to discuss about introduction to the OSI model. The OSI means Open Systems Interconnection Model is a conceptual framework used to understand the functions of networking system. It consists of 7 layers, each with specific rules and interacting in the process of transmitting data across a network. Understanding the OSI model. OSI model is crucial for network engineers as it provides a structured approach to troubleshooting, designing, understanding the complexities of modern communication systems. Layer 1 Physical layer functions. The physical layer is responsible for the transmission and reception of unstructured raw data between the network devices. It deals with the physical connection between the devices and the transmission medium. Components within this layer include cables, connectors, hubs, repeaters, and more. These components are vital for the establishment for the physical network. Examples. Examples of physical layer protocols are Ethernet Wi-Fi and Bluetooth, which facilitate the physical transmission of data. Layer 2. Data link layer. Frame addressing. This layer is responsible for the node-to-node delivery of data and error detection. It ensures that the transmission is error-free using techniques such as CRC, in cyclic redundancy check. MAC address. Data link layer uses MAC addresses to control access to the physical medium. It is where the physical addresses of a network card is stored. Switching. Switches operates at the data link layer using MAC addresses to forward data to the correct destination. Layer 3 Network layer. The network layer determines the best path for data to travel from the source to the destination. This includes handling IP addressing and routing packets to routing their destinations. Logical addressing. IP Internet Protocol addresses the managed at the network layer. These addresses are used for identifying hosts and networks, allowing communication between different networks. Packets are forward biased basic on logical addressing, ensuring that data arrives at the intended destination across differential networks. Layer 4 Transport Layer TCP and UDP provides reliable, ordered, and error-checked delivery of stream of packets on the network. UDP offers an unreliable connections delivery mechanism. It makes it faster but lesser than TCP. Layer 5 Session Layer Communication Control. The session layer establishes, manages, and terminates connections between local and remote applications. Dialog control manages the dialogues or connections between different devices and coordinates who will communicate at what time. Synchronization allows two systems to agree on a procedural order for the dialogue. It also controls interaction between devices and devices. Layer 6 Presentation Layer Data encryption responsible for data translation, compression, and encryption, ensuring that information sent from the application layer of one system can be read by the application layer of another system. Data compression reduces the number of bits that need to be transmitted over the network, optimizing the utilization of the network bandwidth. Protocol conversion handles the differing protocols between systems, translating data for during the communication process. Layer 7 Application Layer Protocols Multiple protocols such as HTTP, SMTP, and FTP operate within the application layer. User interface This layer directly interacts with the end user, providing communication services and network. It enables data to be accessed by the end user. Advantages of the OSI model modularity, interoperability, framework for standards. The layered approach facilitates easier troubleshooting as issues in a particular layer can be isolated and addressed without affecting the other layers. Allows for the integration of diverse systems and devices, ensuring seamless communication across differential platforms and technologies. Framework for standards inspired the development of protocol standards, leading improved compatibility and global communication infrastructure. Conclusion The OSI model provides a comprehensive and structured approach to understanding the complex interactions within a network system. It serves as a fundamental framework for designing, implementing, and troubleshooting modern network architectures, playing a crucial role in the advancement of communication technology.